In this example, I need to solve the equation the square root of the quantity 3x plus 9 minus the square root of the quantity x plus 16 equals 1. Well, what type of equation is this? Notice I have 1, 2 square roots. So this is a radical equation involving 2 square roots, and here are the steps for solving this type of equation. Step 1 says isolate one of the square roots. It doesn't matter which one. So I'm going to isolate the more complicated one, the square root of 3x plus 9, and I'm going to do that by adding the square root of x plus 16 to both sides of this equation. So I'm going to get the square root of 3x plus 9. These two radicals add up to 0 equals 1 plus the square root of x plus 16. So I've isolated one of the square roots. Now I need to square both sides of the equation in order to remove the isolated radical. So I'm going to square the left-hand side, and be careful on the right-hand side, you have to square the binomial. You cannot square each of these terms individually. So on the left-hand side, when you square a square root, they're going to undo each other. So I'm going to get 3x plus 9 equals, since I'm squaring a binomial containing a radical, I'm going to do it the long way by writing 1 plus the square root of x plus 16 times 1 plus the square root of x plus 16, and then I'm going to FOIL out the right-hand side. So I'm going to get 3x plus 9 equals, first term, 1 times 1 is 1, outer 1 times the square root of x plus 16 is just plus the square root of x plus 16. Inner 1 times the square root of x plus 16 is just the square root of x plus 16. And last, multiplying the square root of x plus 16 times the square root of x plus 16, I get the square root of x plus 16 all squared. So this gives 3x plus 9 equals 1 plus, middle two terms, they're like terms, the radicals are identical. I have one of them plus one of them, so I'm going to have 2 times the square root of x plus 16, plus when I square a square root, they undo each other. I just get the radicand of x plus 16. On the right-hand side, I have 2 like terms, so I need to combine them. So I get 3x plus 9 equals 2 times the square root of x plus 16 plus x plus 16 and 1 is 17. So now I have completed step 2. And now it says if this equation still contains a radical, repeat steps 1 and 2. So I'm going to have to isolate my remaining radical. So I'm going to have to subtract x from both sides and subtract 17 from both sides. So this gives me 3x minus x is 2x. 9 minus 17 is negative 8 equals 2 times the square root of x plus 16. These both add up to 0. So to isolate my radical, I need to divide both sides by 2. On the left-hand side, I'm going to divide each term by 2. And on the right-hand side, I just have one term to divide by 2. So on the left-hand side, I get x minus 8 divided by 2 is 4 equals these two 2's reduce, and I just get left with the square root of x plus 16. So I have isolated my remaining radical. Now I need to square both sides again. I need to go on to the next page. Here is the last line from the previous page. So I'm going to have to square both sides. So on the left-hand side, I have to square the binomial. On the right-hand side, I'm going to square the square root. So what does x minus 4 all squared mean? You can do it the shortcut way, or if you do it the long way, you write x minus 4 times x minus 4, then quickly FOIL it out. X times x is x squared. Outer x times negative 4 is negative 4x. Inner negative 4 times x is negative 4x. And last, negative 4 times negative 4 is positive 16. So it's going to give me x squared, like terms in the middle, negative 4 and negative 4 is negative 8x plus 16. So x minus 4 all squared is going to give me x squared minus 8x plus 16 equals, when I square a square root, again they undo each other, I'm just going to get x plus 16. So going back to my previous page, I have done step 1 and 2 twice. And now step 4 says simplify and solve the resulting equation, but don't forget you must check for extraneous solutions. So what type of equation is this? It's degree 2, it's quadratic, so I need everything on one side. So I'm going to subtract x from both sides, and I'm going to subtract 16 from both sides. So I get x squared. Negative 8x minus x is negative 9x. 16 minus 16 is 0 equals x minus x is 0. 16 minus 16 is 0. So I just get 0 on the right-hand side. This is a very simple quadratic equation to solve. I'm going to do it by factoring because there's a common factor of x. When you factor an x out, it's going to leave you with x minus 9. Two factors multiplied together equaling 0, set each of them equal to 0, so I get x equals 0 or x minus 9 equals 0. So x equals 0 is one potential solution, and the second one, add 9 to both sides of this equation, you get x equals 9. But don't forget, we're not done. We must check for extraneous solutions. So I'm going to put the video on pause for a minute. Here are the checks for both of my potential solutions. Remember, we check it in the original equation up here. So checking x equals 0, I get the square root of 3 times 0 plus 9 minus the square root of 0 plus 16 equals 1. 3 times 0 is 0. 0 plus 9 is 9. So I have the square root of 9 minus 0 plus 16 is 16. So I just get the square root of 16. Does that equal 1? The square root of 9 is 3. The square root of 16 is 4. Does 3 minus 4 equal 1? Does negative 1 equal 1? No, that is definitely a false statement. So x equals 0 is an extraneous solution. Now checking when x equals 9. Remember, you're going to put 9 here and here. You get the square root of 3 times 9 plus 9 minus the square root of 9 plus 16 equals 1. 3 times 9 is 27 plus 9 is 36. So I have the square root of 36 minus 9 plus 16 is 25. So I have the square root of 25. Does that equal 1? Square root of 36 is 6. The square root of 25 is 5. Does 6 minus 5 equal 1? Well, 6 minus 5 is 1. 1 equals 1. That is a true statement. So I know x equals 9 is a good solution. So the solution to this equation is there is only one solution, and it is x equals 9.